day. Before we get going with the lightning talks, just a bit of housekeeping. There is still lots and lots and lots and lots of ice cream outside. It's all being paid for, so someone has to eat it. Clearly, it's not going to be me, so please, guys, when you get a chance, go have some more of the ice cream. A reminder that there's the closing social tonight. It's not on premises, it's off-site. Tickets for that are at the registration counter, so please do go pick those up. For those of you who might be intimidated by using the public transport or any other kind of transport to go to the social, some of the staff will be traveling, so you can go with them. You can get that information from them at the registration counter also. And again, for tonight, please don't forget to carry your badge with you, or else it will have been a long trip for nothing. Right, so let's get going. I would like to start with Xiaoliang Wang coming to talk to us about verifiable routing origin. Okay, here we go. And yeah, just to be clear, guys, it's all 10 minutes. That's it, max. No more, no less. Okay, this is the clock.
Okay.
It's ticking.
So
there we go.
Hello, everyone. Actually, I'm Qi Li from Tsinghua University. So I'm glad here to present our recent work on verifiable routing origin. Okay, so the routing security problem is well known. Basically, an attacker can easily, or a misconfiguration can be easily generate fake routing announcement. So now we have an Internet Routing Registry, IRR, use the data to filter the malicious or the fake routing announcement. Also, we have the resource public key infrastructure, RPKI, to verify or attest the routing announcement. So the goal of our work is to utilize both IR and RPKI data to filter the fake routing announcement. So here is the outline. So basically, IR data can be used to filter the fake announcement, and the data is maintained by the IRR, like APNEC, LiPo, and also maintained by large ISPs. So this IR data provide rich information to filter to the fake announcement. So basically, we have 3 steps to filter the fake announcement. First, we need to collect IRR objects from distributed database, and we generate routing policies from the collected objects. Then we can verify the BGP announcement based the generated prefix list. However, during these 3 steps, there are some issues with the IRR-based filterings. First, the IR data maybe have some inconsistency issues. The data in many databases are not consistent with each other. And second, the IR data maybe do not have enough full coverage for the entire address space. And third, the IR data maybe cannot effective to handle the unknown BGP announcement with different specific state. So in summary, the IR data can be helpful to assist verify the routing origins, but solely use IR data is far from achieve satisfied verifications for routing announcement validations. So now the resource public key infrastructure, IPKI, is widely utilized to verify the routing announcement. The RPKI was developed in 2008. The goal is providing verified attestation through ROA objects. So the trustworthiness of the objects is built based on the routing trust from RPKI trust anchors, operated by 5 IRs like Epinic and RIPO. So according to reports from Epinic, the percentage of the BGP announcement covered by ROAs is around 46% for IPv4 address and 53% for IPv6 addresses. So we can observe that the IR data have much better coverage, but the data have some, just I mentioned, that cannot fully cover the entire BGP space. And the RPKI have provided relatively trustworthy results, but the deployment or the coverage is much less than the IR data. So our work is try to utilize the benefits of both type of data to enhance the validation of the routing original announcement. So as the RPKI and IR can't validate all the legitimate routing announcement. So IR provide a low quality data. So it's difficult to eliminate the pointed data in the records. And RPKI provide relatively high quality and trustworthy data, but lacks enough flexibilities because of centralized architecture. So our ROA is try to prove the inconsistency, try to prove the consistency of the routing origin data in multiple data sources, and we aim to support large-scale concurrent validations. So basically, our framework has 3 steps or 4 layers. The first layer is we have a data layer, try to collect the data from multiple origins, for example, RPKI and IR data. And then we have the execution layer. Basically, we use the data to build valid routing origin data. And the data can be committed by the ISP or the IRs. And the third layer is consensus layers. So basically, we verify the data committed by different parties, and if there are any conflicts, then we will, according to the records, the confidence score of each data, to decide which data can be used to update the existing data in the trie structure. The last layer is the application layer. Different party, for example, an ISP can retrieve the data and to use their data to verify the routing announcement. So in summary, our architecture is a verifiable routing origin database built based on smart contracts. So we have data layer, execution layer, consensus layer, and application layer. So we build a distributed database and which provide a high consensus results and high trustworthy results to use for BGP announcement validations. And finally, we also develop a secure routing path validation architecture. So we call the FCBGP. So FCBGP adopts a pathlet validation schema to validate BGP updates instead of path validation schema using the BGP-SEC. And the FCBGP is natively compatible with BGP, and it provides more security benefits than BGP-SEC under partial deployment. The more details can be found in the forum link. Actually, we present in EPNIC 56. Okay, here are the conclusions. So I just briefly describe a new architecture called VRO, a novel routing origin validation framework that ensures strong data consistencies through distributed verifications. And we can use FCBGP to provide strong routing path validations. So compare VRO and FCBGP, we can provide a strong source validation and partial development benefits, and provide strong security guarantee for BGP security. Okay, that's all. Thank you.
Thank you very much. I have time for one question. Nope. Okay, fantastic. Thank you, Charlene.
Thank you.
So none of them know who's coming up next. That's fun. Ramon is going to come up next. There we go. To talk about community networks, CDN, and cloud delivery from Timor-Leste. Red Esperanza. Microphone. Oh yeah, slides are coming up.
Is that?
Yeah,
I'm
microphone.
What is the mic, by the way? Here? Okay.
Yeah, thank you.
Thank you. And I hope with that I can change the slides. I'm Ramon Roca, not Fernando Ximenez. Fernando Ximenez, unfortunately, was not able and was supposed to do the talk because he's the Timorese. I'm not Timorese. Actually, I'm from a Gifinet Foundation. So we were running community networks in Europe since 20 years ago with radio links, and since 2009 with also fiber optics, having thousands of households connected. But now trying to also help in having internet in Timor-Leste, which is a very different context. And let me explain you a bit the background, how it is. There is no internet, actually. At least internet in the way that we understand in a place like this. I mean, because internet is reduced only to mobile. So there is no digital divide in terms of mobiles. The people there have the same mobiles that we have in the rest in the world, but nothing else. It means no residential, no fiber, no nothing. And it's very, very expensive in a country that, the average incoming for a regular person there is about $200, $300 a month, which is a very poor country in these parameters. So within that context, we want to, to provide a real internet there. And in order to make that to happen, as a community networks, we want to try to promote the participation. And also, which is very much in the beginning of the internet. Before internet, the people of my age know that in the 70s, 80s, 90s, internet was built typically by the academia, the educational institutions, and so on. But right now, internet again in Timor-Leste is just a commercial product provided by very few companies, and that's it. So one of the goals is to engage the civil society, and also, and that's why in the Red Esperanza partners within the group, there are many schools that right now have no internet, and nowadays in the 21st century, doesn't make sense to provide education without it. So that's the motivation. And then, therefore, if internet somehow has to be generalized and so on, it should not be in very few hands for large companies, and also to look and enable local economy. Because going fast, I'm sorry for this is a LinkedIn talk, I like a metaphor that explains that. I mean, if you are in a poor country, then the only way to access internet is as a commercial product, which is more expensive there than it is everywhere in the world, is like, if we look into the what's first, the chicken or the egg, and you want to create this, the virtual circle of having both. What happens if you only eat the eggs and you never will have a chicken? Actually, is what's happening. So there is no local economy, and at the end of the day, the economy, and sometimes that's a big warning. I mean, if we want to develop a country which is very poor, what we could not do is to extract, maybe 20 or 30% of the GDP, extracting the money from the locals and then send to companies abroad. So we have to create a circular economy. And so what's to do in order to break that vicious circle of what's first, the chicken or the egg? So first to create a network, a real network, not only mobile. Now there is lots of technology, chips, we can develop, now we have plans to lay out fiber, and for that we need to solve some operational challenges, like not having electricity is one of the biggest challenges, but also develop the local skills, and that's the thing. And the big challenge now is to provide the last mile, which is non-existent, only mobile again. And mobile is, okay, it's good to have, and I'm not against the mobile, don't misunderstand me, but we have to provide the other last mile, which is absolutely missing. It's also other things which have to look at. And what it comes first, we don't know, but for instance, international exchange, I mean, here in the lobby, you have seen lots of internet exchange from Bangkok, from Japan, from Amsterdam, from whatever, but there is no wholesale access at all in Timor-Leste. And maybe that's the crazy idea. I mean, if you are familiar with the fiber, often it's used as the fiber to the home, right? So fiber to the home is up-down initiative. So from the companies, they connect fiber, bring fiber to the home. So our crazy idea is, okay, starting with the schools and fiber from the schools to reaching the home. So it's an absolutely different approach. It sounds a bit crazy, but this is a LinkedIn talk, so it's about these kind of things. And that's what we are doing. This is what we are trying to do in a very rural area in Timor to happen this summer. And also by having that, then also encourage, to get more capillarity through point-to-point radio links, which is very much what community networks have been done forever, right? And those are some diagrams and pictures of myself with the locals and antennas and doing things. So, oops, this slide doesn't look good, but very shortly, briefly, now we are, to vertebrate a community, you have to create content, right? So we are doing from the schools, and in the next slide I will show you. I'm sorry for having that not well painted, but I will explain you what's there. First of all is create the cloud services in the schools, providing, e-learning tools, capabilities, and so on. Now we are trying to build the fiber optics, deploying in the one advantage is that country is not big. It's a small island, and so we can do, with a few kilometers, we can reach quite a few people, even in rural areas. And then from there, create the wireless links to reach the more rural areas. So that's very much so we are going to start in the opposite side that we did traditionally in the community networks. Instead of starting wireless and then go fiber, we're starting with creating the content itself, because there is no gateways in a reasonable price accessible there, and trying then to provide the fiber backbone and then the wireless thing. And just to give you some, well, I don't have to here explain use cases of internet to happen, but here are some pictures of, in the picture in the top, you see the nuns, which are the teachers that are really amazing people, creating content as long as they have, tools like Moodle for e-learning and so on. So, And the man in the middle is the president of the country, is Jose Ramos Horta, which was also a Nobel Prize. And there are the children with tablets and so on. So as long as you give the tools, even in a country like this, they quite easily become digital. So it makes sense to do that. And this is myself with Celestino Amaral, one of the colleagues there, installing the servers, which is what we already did. Now we have to go for the next step, which is the fiber. And very last, still on time, this is very much the infrastructure, because typically when thinking in rural areas, in places with no internet and so on, and that's the other crazy idea, is about, installing there very simple things and not sophisticated and so on. In your case, we are doing in the opposite way. Let's see, in the opposite way. Let's see how it's going to work. But what we are deploying, and also we are cooperating several organizations worldwide. I mean, Gifinet is from Europe. We're also in cooperation with people from Argentina and now Timor-Leste. And the tools that we are deploying is like provide all the cloud services, but even in places like Timor-Leste. So some people think that we are crazy but those technologies really can be, I'm talking about, next equivalents to Google Drive, to, identity management. People there don't have IDs and everything. I'm finishing my time. I hope you understand something, but thanks for allowing me to give this talk.
Thank you so much. No questions? All right, thank you. Next up, we'll invite Aftab, who's promising that this will be the last word in Bogons.
Would that be okay if I say trust me? Right. So definitely, I'm going to talk about it later, but not that much. Yeah. So biggest issue, I am representing Internet Society right now. I normally represent myself in that room, but here I'm representing myself. So one thing is, right. So Bogon has been discussed quite a lot in the past. I have written about it. I've discussed about it. So the question comes up quite often that why we need to redefine what Bogon is. So I'll go through a few points and I'll explain that what is the problem. So this is the definition on APNIC website, apnic.net. That what is a Bogon? IP address space reserved but not yet allocated or delegated by the IANA or delegated regional internet registry. The areas of unallocated address space are called Bogon space. So remember the words unallocated or delegated by IANA and or by RIRs. So let's look at the definition in journal. We found this when I was looking up for the definition in the past. It's back in 2003. Someone did attempt to provide an explanation of what Bogon is. So the word actually comes from Hitchhiker's Guide, Wogons, and then it became Bogon. So again, you can have a look at what a Wogon is. Again, it's a Hitchhiker's Guide reference. We don't have to go into the details, but most of the things on the internet are actually coming from the Hitchhiker's Guide. So moving on, in the RFC 3871, there is a further explanation of the word. Packet with IP source address in the address block not yet allocated by IANA or the RIR, as well as addresses reserved for private or special use by RFC. So that expand the Bogon definition a little bit further. So starting from just unallocated address space from IANA and RIR to adding reserved and special use case addresses reserved by RFCs. of course, Bogon is something, Team Cymru is one of the pioneer in highlighting this issue and have been providing Bogon list via text file, via DNS, and via BGP feed for many, many years, if I can remember. And we do have our friend Yakombo from Team Cymru, or Team Cymru, that's how it should be pronounced, who can give you more details about those services anyway. So it's been defined as, on their website, that it causes a lot of problems, so it should be filtered. And many operators have been filtering it quite nicely for many long time. So on the same Team Cymru or Team Cymru website, you can go and look at the Bogon. There are two types of Bogons. One is Bogons and the other one is full Bogon. In the full Bogon list, there is a slight difference where it says that available, unallocated means available in RIR as well, unallocated by IANA. So it gives you a little bit more clarity that what actually is a Bogon. But moving forward to CIDR report, where the actually confusion started, from where the actual confusion started, they list down Bogon in this manner: unallocated address space by IANA, reserved address space by IANA, unallocated address space by RIR, and reserved address space by RIR. And that was a contentious issue, right? Nobody else mentions that reserved address space should be considered as Bogon, but CIDR report does. And it was a problematic, it was problem for us in manners when we were calculating Bogon in the global routing table. So we did look at the NRO, and we figured out, well, NRO is the best place to find out the best definition, who can define it. Well, NRO consists of the 5 RIRs. So I reached out to them more than a year ago. I think it started before Manila. Singapore it was, I think, if I'm not mistaken. And then we had multiple meetings, multiple discussion. And the group is called RSCG, which is a Registration Services Coordination Group within the NRO, which consists of all the members of the registry side of the RIR, and they sit and discuss policies together. And they all came up with the final definition and agreed with this definition, and we can close this discussion that what is a Bogon. So I'm going to read. For APNIC and LACNIC, as both have implemented RPKI AS0 policy, which is a separate TEL from the existing RPKI TEL. Address space mentioned in their respective AS0 TEL route origin authorization must be considered as Bogon. So if you take the AS0 TEL and open up, you will find a lot of addresses in there, V4, V6 together. Anything mentioned is there from APNIC and LACNIC should be considered as Bogon. For the remaining 3, AFRINIC, ARIN, and RIPE NCC, any address space marked as available must be treated as Bogon. Additionally, any address space marked as reserved and remain in this status for more than 180 days. So if today an address space is marked as reserved, after 180 days, this will be marked as a Bogon, not in the RIPE NCC or AFRINIC delegation file, but anyone who's considering what Bogon is. Exclusion criteria: address space that does not meet the conditions mentioned above should not be categorized as a Bogon. So that cleans up the definition, and now we have a winner that what actually is a Bogon. So that's all from my end. We will be generating a Bogon list. We will be talking to our partners. One of them is, of course, Team Cymru, APNIC, and other RIRs, and providing them this list, because now we are generating a separate list for people to have a look. I don't have the URL for that because we need to verify a few things. But hopefully soon you will see that on the Manners website through a blog post. So that's it from my end. If you have any question, the only message I have is now you should stop propagating Bogons.
Excellent. Thank you so much. right, next up is, you sniffed it, was you. Next up is Bart from Cisco, speaking about energy savings and QoE are friends.
So this is a quick talk to really talk about sustainability. As you probably know, energy cost has risen very dramatically, especially in Europe over the past few years. And I wanted to, talk about how you can actually try to combine using less energy and maintaining quality of experience for end customers that are actually consuming your internet or broadband service, specifically for mobile networks. Because effectively, when we took a look at the usage of energy in networks, what comes out very clearly is that there's a lot of improvements in utilization of energy in fixed networks going on, mainly due to the fact that fiber to the home deployments are increasing, and therefore, older technologies like DSL are disappearing. And then radio access becoming, a massive part of the energy consumption on a per user or a per gigabyte level. And I got a few data points here just to leave for you to your reference. Omdia did I think a good study on what the various parts of the network actually consume. But again, there, mobile RAN is essentially the big user of energy. And in fact, it's not really surprising because these are, class A, B amplifiers that are being used. And first of all, you have to have them on to, be able to connect people. And they have to, even in idle, dissipate significant power to have reach in the area they are covering. And then when utilization goes up or people start connecting, actually, it even increases more obviously. But in any moment in time, a radio is consuming significant power. And even GSMA agrees with this. This is not some lone wolf explaining, radio access networks are consuming a lot of power. There's a study from GSMA that did concluded the same thing. So what we really want to try to do here, and this is the idea we came up with, is essentially, can we actually start combining a set of data, get more information from what's actually going on the network, and then start creating from that information a knowledge database which will correlate IP traffic to users, where they are, what power is actually being consumed, and then create a capability to action upon that knowledge that is now generated, and do that in near real time. Because you could say, just switch off radios, right? Just you see certain utilization, start switching off radios. Now, the problem is if you purely do this on a radio perspective, you're essentially starting to switch on and off on the basis of load on TDM slots or frequency slots, transmission slots that are directly at the radio site, right? And that has no correlation or relationship to actually the real IP or application consumption that's happening on that particular network at that moment in time. So you actually are going to have a tough time figuring out how you are affecting, in a good way or a bad way, the user experience. So essentially, we're combining here IP flow metrics, measure what's actually going on in the network, linking them to the RAN KPIs, what's the guarantees that we're giving for customers, and then you can start optimizing and deciding where to contain certain spectrum usages in the network. And with that, you can actually achieve two goals, which is why I called it They Are Friends. And the way this is effectively done is, you start monitoring a certain area in the network, you know which users are on there, you can get data from packet core infrastructure, you know which radio bands are in use, and you look at the flows that are going over the network. You understand all this information, you start correlating it, and then you can present a decision to actually say, hey, this frequency is underutilized, I can switch it off and push people automatically to other frequencies bands that have enough space in this particular geographical area. And so we essentially, because all the traffic is encrypted, and I talked about it at the CDN panel earlier this week, you effectively cannot look exactly down in the packets because everything's encrypted. So what we do is essentially you observe the IP headers and the time domain of the flow, and essentially start creating a per flow data record which you enhance and enrich with site information, DNS information, SNI, whatever you can still see, as well as the actual radio information, user information that you get from a mobile network. And that will give you an attributable or an actionable data set that is adhering to a certain set of goals that you have for your end customers sitting on the network. So essentially, it's all about actionable data, and the RAN performance app that you can derive from that is one example, but as you start working with this, you can imagine you can generate other applications serving other purposes in this space, because you're sitting on an actionable, identifiable data set which links users to applications and to network utilization, including the radio. So it's actually a way where you can generate a lot more savings too. So the blind cutoff, switch off of frequencies versus actually this, I'll call it smart way of linking IP flows to the radio networks is in our tests showing quite significant differences, up to 5x, 2.5x improved speeds. And we did some testing, and I wanted to share this with you. This chart shows you 4 frequency bands, and the colored bars that you see are all 15-minute opportunities for switching on and switching off frequencies, so you will reduce the energy utilization, right? And you see there's various sectors here. Sorry, the sector 1, 2, and 3, it's unreadable. But for instance, sector 3 here, there's like almost a continuous opportunity to switch off 75%, or even in certain cases, 100% of the frequencies, because there's effectively no need to be running them. So, there's an opportunity here to better understand what's actually being consumed in the network, link it to frequency management, and at the same time preserve the goals you have in terms of throughput and experience for end customers on your radio network. So, very fast talk as per my instructions. I hope this gave you a good view, or an initial view of what we're doing with IP flow inspection and correlating it to frequencies. Thank you.
Thank you. Any questions for Bart? No? All right.
Okay.
Thank you so much. Appreciate it. Next up, we'll have Akio Sugunu talking about how peering at the New York IX helps the US school system. Thank you. The microphone is up there. Yep.
What's this? Oops. Good afternoon. My name is Akio Sugano from NIX. Today I'd like to talk about how peering at NIX helps U.S. school market. So by the way, how many people attended yesterday's peering forum? Only a little bit? All right, great, great. So let me, how do I, so the next one, okay, sorry. So for those who didn't attend the yesterday's forum, let me explain NIX in briefly. It's founded in 1996, and our largest IXP in the US East Coast. Peak is 1.7 terabit. And peak is 1.7 terabit. And we have over 220 members. And we've actually 2 locations, New York and Los Angeles, but I'm talking about the New York location today. And we have 5 hubs in New York, 2 hubs in New Jersey, and 1 hub in Philadelphia. Okay. So out of the 220 members, we have 5 SCO members. First one is the NYSERNet. NYSERNet is a kind of non-profit organizations which provides network service to colleges or universities in New York State. They have over 100 members. And NJH is another non-profit organizations. They provide network service to colleges, universities in New Jersey State. And also we have the Internet 2. Internet 2, they provide network service to all colleges, university in nationwide. And in addition to these 3 members are like an aggregator. They peer on behalf of their members. Also, in addition to 3 aggregators, we have 2 individual customers, like Rutgers University. Rutgers is the public school, public universities. They founded almost at the same time as Ivy League was founded, pretty old university. Also, we have one Manhattan College. They're a private college based in New York, and their CIO is very familiar with peering, so they are very happy with the peering over NIX because they have heavily rely on Google Suite, and the performance is much better than typical transit cost. And now, one new customer joined NIX December last year. They are representing Pennsylvania State. And they have a huge improvement in New York network performance while reducing the operating cost. So this is a picture of the Pennsylvania State. Pennsylvania has about 40 million people in populations. Considering New York State has 8 million in populations, their state is pretty large. And these are divided in 29 IU. IU means intermediate unit. And each intermediate unit is responsible about 15 to 20 school districts. So like any black-colored one is the school district. So each school district has at least 4 schools. In the United States, we call it K-12. K means kindergarten, elementary school, middle school, and high school. So the previous page, we are talking about only higher education, meaning colleges, universities. But the US market, K-12, kindergarten up to high school started have a heavy network operation and started peering at our exchange point. So each has 15, 20 members, and about over 500 school districts in the Pennsylvania area. That means each school district has 4 schools. Again, kindergarten, elementary school, middle school, high school, means we are talking about over 2,000 schools. So these schools are started to join and started appearing over NAICS. And first one is Lancaster, Lebanon. That's called IU 13, one of the 29 IUs. And they provide about network connectivity plus IT, meaning PC, printer, plus all IP network. About 20 school districts in Philadelphia since 1995. And they have pretty good network operator engineer because they understand BGP, they know how to operate BGP operations, stuff like that. So they're pretty capable. And they also have a lot of the data, statistics data, so they can tell Google, Amazon, Akamai, Apple, Cloudflare, and Microsoft. This accounts for 70% of schools. And typically, US market, US school has lots of the Chromebooks. That's why they need to pair with Google. They have lots of the IP Apple devices like iPad. So, and the problem of the Pennsylvania state is they have only one large ISP dominated. They have no choice but choosing one provider. If you don't join, have their service, they have no internet. So they're so unhappy with the current condition. So however, they started to peer over NAICS, and significant amount of traffic is bypassing the transit and going to directly to these, Google, Akamai, large content providers. So the last thing that says, this is for the first time in Pennsylvania state or IU 13 in 30 years history to finally reduce the transit cost. As you know, the transit cost has been decreasing. However, this one large cable provider keep increasing the cost. So state-wise, they are not happy with it. So action plan, we closely working together with Lancaster, Lebanon, and more eyes are coming and join NAICS and Philadelphia. So now to reduce that cost and more performance. That's it. Thank you very much. I appreciate it.
Thank you very much, Akio. Any questions for Akio? All right. Next up, we will have Shane Alcock talking about internet outage detection and analysis. Microphone. Yeah.
Okay, hello everyone. My name is Shane Alcock. Today I'm wearing my freelance consulting hat, and I'm going to be talking to you about a project I'm involved with called IOTA, Internet Outage Detection and Analysis. So this is an academic project out of the Internet Intelligence Lab at Georgia Tech in the US. It's led by Professor Alberto Dainotti, who you may have heard his name once or twice already during this conference. He was formerly at UC San Diego at CADA, and he's since moved to Georgia Tech. And my role in the project is to assist with the development, integration, and deployment of the IOTA software. So what we're trying to do with IOTA is provide a service that gives near real-time detection of what we call macroscopic internet outages. So rather specifically, we're talking about outages that are fairly visible at like a country level or at a sort of subnational regional level, or for a particular network or AS. So there's quite a few causes of these types of outages that we're interested in. So things like cable cuts, natural disasters, weather events, shutdowns that are forced upon operators by governments, the impact of war, human conflict. We've seen a lot of interesting outages coming out of places like the Ukraine and Gaza in the last couple of years. Cyber attacks, of course, and also just plain old operator error can be a big contributing factor. So the way that we do this is we collect a variety of measurements and then break them down by these per country, per region, per AS level. So we collect BGP data from route views and RIS, and we are looking at calculating the number of visible /24s for any given, again, country, region, AS, so on. And that gives us sort of a baseline signal so that we can look for changes in that to infer outages. The other signals that we collect, active probing, so we measure the number of subnets that respond to ICMP ping requests. We also look at background radiation that's coming off of network telescopes. And lastly, we've integrated in the Google Transparency Report data, which is a public repository that they make available to indicate the approximate level of traffic that Google sees coming out of particular countries for various services. And then we put it all up on the website, and that's the URL there. I'll flash it up again at the end if you need to copy it down, but it's not hard to remember. And that's what the website looks like. If you go to the dashboard in the front, you can see it brings up a map of the world, and it colors in the various places where we're currently seeing outages. And you'll see not the greatest resolution, but you can see we can flip tabs from region or to look at a particular network. And there's a search bar up there, so you can just type in your AS or your country or whatever you want to look at. I'm running through this very quickly, which is great. I'm just going to throw up a few examples of some outages that we've observed in the APNIC region or in and around the APNIC region over the last year or so, and how they appear in IOTA. So this is the first one here. So this is internet connectivity in Papua New Guinea during some recent civil unrest that they had in January. And you can see that we've pretty clearly spotted a case where there's probably been some damage to the infrastructure, and that's caused a dip in our signal, and we can highlight that. Another outage, this is one that we've probably heard quite a bit about over the course of the conference. So this is the Optus outage in Australia last year. And you can see it's a very obvious one in this case, so we picked that one up. This one here, I've actually turned off the alerting bars because they were just all completely covering up the signals. I want you to be able to see the signals better. So this is Vanuatu, pretty much 1 year ago to the day now. They were first hit by Cyclone Judy, which would be, around about here where we see this drop off. They hadn't recovered from Cyclone Judy when Cyclone Kevin arrived 2 days later and took out whatever really was left. So we can, we have these this insight into these events that are happening. We can see that communications are going down and that people may need assistance. This one here, this is Pakistan. This was earlier last month. And you can see just in the lead up to the elections, something happened around about here. Sorry for the people on this side. Around here that we've picked up on. We're not quite sure exactly what that one is. But you can also see election day here, where we've got these big drop-offs in a number of the signals. They definitely did shut down the internet on election day. And lastly, this is the Syrian Arab Republic. So this isn't quite in an APNIC region, but it does highlight a particular cause of outage that some people aren't always aware of. These outages that we're seeing here are the government shutting off the internet during exam periods for students. And as you can see with the massive drop in the signals, they literally shut off the entire internet for the entire country. So it's pretty devastating. We also see these types of outages in India, but they're on a much more localized basis, so they don't always show up in our graphs. And really, that's all I wanted to say is, yeah, that's IOTA. Feel free to check it out. Certainly, I hope it gives you some insight into what's going on in your region and around the world. One thing that we'd love to hear more from is from people in the various countries around the APNIC region, giving us feedback. What outages are we picking up well? Are there outages that we're missing? Are there things that we need to do to improve the quality of our data and be more accurate of the situation that's actually occurring? So if anyone has that information and wants to share it, then feel free to reach out to us at that email address there. Thank you.
Thanks, Shane. Any questions for Shane? I think there's one question for Shane.
Since there's time. Hi, this is Robert from the NCC. How real time is this?
It depends on the data source, admittedly. So there's a little bit of a lag, but for things like our BGP signals and our active probing signals, we see them within half an hour maybe. That we have the data, and sometimes the alert detection algorithm can add a little bit more lag onto that. So I say near real time. It's within the hour,
Right.
easily.
And the Google part?
That one's a bit more of a lag. So that's more of a we tend to use it a bit more as like a confirmation or a additional source of information. They publish the data, I think it's roughly every 3 hours, and they also introduce their own lag into that. So it tends to be about 6 to 8 hours behind from memory.
I think that's totally reasonable. Are you considering other data sources still?
Absolutely. We always got something in the pipeline, so I'm not sure if there's anything I can announce just yet, but there are more things coming.
Fair enough, thank you.
Anurag?
Anurag Bhatia, Hurricane Electric. I think you said you detect based on BGP and BGP announcements as well as ICMP. Is that correct?
Correct, yes.
How would you look for mobile networks in such scenario, especially as they go more and more towards V6? So you would see like a large V6 aggregated block across larger areas.
Yes, so at the moment our measurement focus for this is primarily V4 visibility. So we look at the number of visible /24s for a particular region or for a particular network. We collect the V6 data, but we haven't quite integrated that into the system. I imagine that would be a slightly different signal. I wouldn't try to munch them into a single signal for obvious reasons.
Thank you.
All right, thanks, Shane. Next up, we'll have Christoph Visser talking to us about big stuff happening at Steam.
Good afternoon, everyone. I'm Christoph Visser. I'm from IAJ Lab. I'll just preface by saying that I don't actually have anything to do with Valve or Steam. These are just some of the findings that we found for a paper that's being presented in a couple of weeks in PAM. And as the title comes about, it is about Steam's content delivery platform. So the first question is, why are we looking at gaming as such? Normally people look at investigating this topic focuses on reducing latency between your users, preventing DOS attacks, and now more recently there's the whole cloud gaming and streaming. However, for a lot of network operators, the impact that they're seeing to their networks is actually like when big games come out. And I think the one at the top side shows the best example. While COVID happened, everybody was stressing, are we going to have enough capacity for people working from home? That didn't tend to really be the issue. It was actually the biggest spike that they saw was from the release of a big Call of Duty game, and it was a free version, so a lot of people download it and play it. And a lot of people still see impacts whenever there's a new big Fortnite update or release coming through. So what is it that makes this gaming content, like the characteristics so unique that we see these impacts? Overall, I'm just going to very quickly go through this, but whenever a new game comes out or an update comes out, people are quite impatient. They want it like as soon as possible. And the thing is with these games is you need to have the entire thing downloaded before you can start playing. So you can't offload, like distribute the traffic like you would do with a streaming service. And these games are getting larger and larger. So last year there was a big game came out called Baldur's Gate 3, and that is about 150 gig in size, and it was also extremely popular. And it actually had Steam's traffic go from about an average of 15 terabytes per second to 150 terabytes per second. So our question was, how do they manage to deal with these peaks in traffic, almost 10 times increase? And the other unique thing is that, especially on the Steam game platforms, these games all come out globally around the same time, or not the same time, exactly the same time. So we see an impact globally happen for that. So how we found out a lot of our data is actually we kind of reverse engineered how the Steam client actually downloads the data. And from that API, from the API that we got, we could find where they host their location, Steam location or cache locations around the world within data centers. This is slightly outdated because recently found out that a lot of ISPs are also hosting that as well. So we are not including that just yet, but we are investigating it. And the amount of data that we actually get from these APIs is extremely transparent. It's really nice. So we can actually not just see all of the host names, but we can see the load on each individual cache. So if we look at, for instance, in Tokyo, within the data centers there, we can see there's a nice distribution. It's evenly distributed load balancing between all of the cache servers. And we've just put the, whenever a server is no longer being advertised, we give it an artificial load about 100, so it's easier to read. So what does it look then during a game release? Well, we've increased the scale here to still make the traffic line fit for the Asia region. But the big thing to note is while the load flattens out, the traffic keeps going up and it doesn't really slow at all. So that tells us that this traffic is coming from somewhere else. And we were trying to figure out, well, where does the traffic come from? So skipping up a little bit forward, because it's covered in paper, but we kind of took the average of all of the caches within a region and got that value. I think the South America one is probably the best example. You can see it flatten out, but the traffic keeps going up, which means that these servers are no longer being able to provide this traffic at all. So again, the question is, where does the traffic come from? So going back to the API that we actually use to get our data, and this is just a quick sample of what we get. So we receive all of the caches that's available for a client in a priority order list. So while there are still Steam caches available, it will keep picking through the servers until essentially your link is saturated. So in this case, there's a couple of Steam caches available, and this is, for example, in London or in the UK. So your Steam client will go and actually use those caches. However, during those times when there's none available, essentially saturated, we now see that actually the only ones available is your third-party CDNs. So they're using a very clever hybrid CDN type of approach, using a lot of their caches to start off with, and then during these big peaks, they're offloading their traffic to the likes of a third-party CDN. So then our next question was, well, how viable is this approach? How good is the job that they're actually doing with this? So in order for us to get an idea for that, we mapped the traffic and the average load for all the caches in the region and map them out. So we see that it matches quite nicely. And then as soon as the servers start disappearing, we give it an artificial load of 100%. And we see, especially again with South America, North America, Europe, that we have a very long tail here on the right-hand side, which indicates to us that they're really using these CDNs, not just willy-nilly, but really when these big game releases come up, when there's a lot of data or traffic that they need to send out. And another perspective of that is how well do they actually do? So if we look at all of the regions where these caches are available, we can see that the amount of time below that estimated cache capacity, the Steam cache servers are on average serving like just over 90%, or not on average, they're normally more than 90% being able to serve the content when being requested. But just on the next table over, we can see that actually the amount of traffic that they're able to serve is less. So again, affirming that they're using these CDNs to like really make up for the times when they're being hit hard with these big game releases or big updates. Now, the elephant in the room, of course, is South America. While they are only able to serve the content about 60% of the time, the percentage of traffic that they can accommodate with is just over 30%. And even between our estimated cache capacity and the maximum peak that we saw there, it's about an 8.5 increase. So for us, that indicates that this region is really a place that can use a lot more of the Steam caches to help offload some of that traffic load. And I'm still good on time, but essentially this is still ongoing research. Like a lot of this was just more exploratory, seeing what good things we can get from just purely public data and what's available. So we're going to keep monitoring this. And I think a nice thing of this is maybe if you're a content provider or want to be one, a hybrid CDN is a clever way of kind of doing some of that offloading. And from what we've seen is they're not giving up this idea anytime soon. They are still actively deploying more and more Steam caches. So they're not going to a full third-party CDN structure anytime soon. And that's pretty much it. I'll leave the rest up for there, but I'll leave some time for questions.
I have a question.
Yes.
So are Steam aware that you're doing this research on their network?
They are. I have reached out for comment about it. They are happy and interested in the work they're doing, but because this is all public information, they don't really want to comment too much to influence it. Maybe at some point I'll share a beer or two with them and find more details, but they are aware. They're happy for us to keep doing it because they've got over 130 million active monthly users. The amount of data we're collecting is negligible for that.
Right. I mean, so obviously they are collecting significantly more data than this because it's their network, right?
Yes.
So my next question then would be for you is, so it's just out of interest, like you're bored and you want to find out, or I'm really just curious, what's the end game? Like what's the goal for you to get to?
So for us, long story short, how we came upon this is a couple of years ago, there was a big trend in people playing chess on chess.com, and they collect a lot of latency data. So we were interested, a lot of people play that, but we don't, as researchers or network operators, we don't get access to that. Is there other platforms that we can look at similar type of data? And we found Steam not only publishes the traffic data that they've got available, but we were able to access the APIs for all of the Steam caches, etc. And actually one of the future research and comparisons that we want to make is we're building a data set where they also publish the top ISPs per country. What is the average download rate, the total amount of bytes they're downloading. So comparing that to the likes of maybe like a CADA AS rank or even the APNIC one would be interesting to see the differences. So for instance, in New Zealand, the biggest ISP is Spark, but based on the amount of data downloaded, they're only ranked third on the top ISPs for Steam. So it's a different way of doing comparison there. So it's more just interesting to see that we can look at this.
Thank you so much. Anyone has any question for Christoph? All right. Thank you very much, Christoph. So next up, we should have Robert, RIPE NCC, a short talk on using RIPE Atlas. On the side? No?
Well hidden.
Yeah, over there.
All right, well hidden. Hi, I am Robert from the RIPE NCC, and I'm going to talk a bit about RIPE Atlas. It's not going to be a full training on what it can do and all the features, but since the system has been mentioned a couple of times this week, and it was very heartwarming to see so many of you actually using it, I figured that the ones who are not using it could have an intro, but also I will probably flash out a couple of things that might be useful for the others as well. Oh, this is the old slide set. We have a newer one. In any case, the first slide is going to be that when you want to start using Atlas, the system works in what we call credits. It's basically an ecosystem that if you provide resources and more vantage points to the system, then you can get the rights to actually use the system. So for this, we are using what we call the credit system. If you run a probe, if you run an anchor, if you are a sponsor, and there are a couple of other ways that you can get credits, and therefore you are going to use those credits to schedule your own measurements. Now you can use any of the probes in the system. So the whole point is that you run your own probe in your own home or your own ISP, but you can get the other probes to participate in your measurement. Okay, let's try this. Still the same one. All right, anyway, I'll use this, never mind. So you have two options. You can use the UI that we provide, and this is the measurement form where you can specify what you want. And we try to make it really, really, really simple for people to use it. So if you want to do the simplest thing, you only have to press the ping button, because then you want to schedule a ping measurement. You enter the target, the destination, and then somewhere at the bottom of the form, you just say go. There are a whole bunch of options that you can play with, but you don't have to. So the system just does good defaults. And when you do, you get results like this. So we give you charts. So this is, I think, the result of that ping measurement. We give you maps. You can download the data. You can set everything. But some of you might be more inclined to actually do some development, and we also support that. So we have an extensive API behind Atlas, and you can use that via a number of tools. The development team for a long time has been publishing Python-based code for parsing the results, for talking to the API, and there's even a command line interface, so you can just install it and say, measure this thing, and it will happen. But yours truly also wrote a new one in Go, which is an API wrapper and all of those things together. And binaries are available, so Go is good because you can get a single binary and then you just run. So let me show a couple of examples of what you can do and show you how easy it is. This is the tool as it is today. So when you say, okay, what can you do? You can find probes, you can find anchors, you can find measurements in the system, you can look at results, and you can measure stuff. So let's see how that works. First question, what probes are online in Thailand right now? So then what you say is find probe where the country code is TH for Thailand. And you get basically immediately this result. What you can see here is that the probe ID, whether it's connected, because you can also search for non-connected probes, which ASN is that in? So that's kind of useful. This is the ASN in V4 space and ASN in V6 space, which could be different. For example, tunneling. Geolocation of the probe and the name of the probe. So that's simple enough. Everything that outputs goes through what I call output formatters. So by default, you get some layout, but that's modifiable. There are more advanced things for that. Okay. That's pretty white. That's not cool. There was content here. All right, so the missing slide, as you can clearly see, I was searching for anchors in RIPE Atlas in Thailand, and the result was that there are two. So goat, find anchor, -CCTH, and it gives you two results. Then, let's ping one of those from 10 probes in Thailand. So the only thing you need to do is you say, okay, I use -V just for kicks, go to ping, this is my target, and use country code 10 probes in Thailand. Then the system goes off and the -V is there so you can see actually what happens. I'm using an API key, of course. And then it says, fine, so this is the results of your measurement. So what happened in the background is this tool scheduled a measurement and immediately tuned into the result stream to get live results. And then produces and shows you those results. Notice that we began listening to the stream at 29:10 and it ended at 29:21. So in about 10 seconds, you got these results from all of the probes. And what you can see here is the measurement ID, which probe what it was, at which point in time, what was the target, name, address, and some ping statistics, packets sent, received, and then minimum, maximum, and that kind of stuff. That's normal. Now, of course, the point for Atlas is that you can use the whole system. So now we can do the same thing from Singapore. The only difference is that I said SG there, but otherwise the outcome is the same, as you can expect. And then we can go wild and we can say, but within the region is nice, but we can also measure from Germany, and in this particular case, Deutsche Telekom, because why not? All right, then the next question. If you run an anchor, then your anchor is immediately involved in a full mesh of measurements, so you don't have to schedule any kinds of measurements. We do it for you. So about 800 other probes, or anchors in this case, immediately starts measuring you. So what measurements are available against this particular anchor? Well, here's the list. That's nice. So you can see that we do HTTP, ping, and traceroute measurements all across the anchors in V4 and V6 space as well. So then I picked whichever the number was, and I said, well, let's start listening to the results of those. So this is essentially the same thing, except that I didn't schedule anything. The system already has this built in. Whoa. Don't do this to me. On the slide that will hopefully be available on the website, I will have more examples. In the meantime, I will talk for those. So you can, as I said, there are output formatters. So one of them that you can use gives you statistics about DNS results. So if you do a DNS measurement, okay, we're here. If you do a DNS measurement, then you can say, now please aggregate all of those results by ASN of the source. So you will be able to see that, this kind of answer was given by probes in ASN A, B, and C, and that kind of result was given to you by probes in a different ASN. But coming back to this, I did nothing else but to tune in to the stream, and this is just scrolling down the screen endlessly if you let it. Now, for the people who are inclined to actually program, this is all it takes to schedule a measurement in Go. So you just say, well, please, let's make a new measurement. I will want to use my API key because I need to do that, otherwise the system will not know who I am. I want to add probes. This is a list of probes. This is 15 probes from a country, and this is another set of probes from this prefix. So those are my probes. Please start it tomorrow, so this is the date. Make it a one-off. And now what measurements do I want? Let's add a traceroute measurement, and then some parameters you need to give. Go. And then the results come back if there was not a problem. For example, if my API key was wrong, then the system would reject me. Then I have results. Then you can say, okay, now I want to filter results of the whole system to this particular measurement. Please turn on the streaming. Okay, give me those results, and this is just a for loop. It does whatever you want it to do. That's it. I had other use cases in other slides, so as I said, I hope that those will be up on the website. But if you're so inclined, go and try it out. Thank you.
Any questions for Robert? No? All right, thank you. Next up, we will have Meinl. Meinl, yep, there we go. Meinl is going to come and talk to us about AI safety in the network.
Hi, a quick show of hands. How many of you have used ChatGPT? How many of you have used ChatGPT Plus, paid for the service? Okay. About me, I am the founder of a company called Jonathan Wi-Fi. We do software for network providers. And we have been funded by APNIC ISI Asia grant. Also, we are part of Microsoft First Startup Founder Hub. So we get a lot of cloud credit to play around with GPT-4 APIs. And we have access to a big network in Bangladesh named Link3 to test some of our ideas. So how do I change? Do I use this to change the slide? Green button, okay. Got it. Okay, so what is AI safety? So if we are talking about minimizing harm, I got these points from OpenAI's website. They talk about these things officially. You can go look them up. But in summary, you can have a long debate about what harm means. But for us, let's say it is unintended consequences that can cause you financial, emotional, or reputational distress. So what the typical work of AI safety consists is a lot of operational work in figuring out if you have trained a model, how does that model perform? Does it have unintended consequences or behavior? Figure those out and then train it to behave it in a way that it doesn't do that. And also you keep pushing the updates to the public to build trust, to see how it is behaving, how the public is interacting with the AI, and it's a long learning and iteration process. Okay, so the problem is AI is getting access to tools. If you have used ChatGPT Plus, you'd know that it has access to a coding tool named Code Interpreter. It has access to a browsing tool. It can browse the web. It has access to DALL-E. And if you are making any GPT in the GPT store, you will know that it can call APIs as well. If you give it a YAML file, it will know how to call the API. So, and you can keep building tools for it. For example, in our organization, we gave it access to a web browsing tool to go fix level 1, level 2 support problems. So a lot of these tools, it deals with the open web. Now, when it is interacting with the open web, at the very beginning, like if you remember back in 2023, March, April, when they were just releasing these tools, web browsing tools and whatnot, there were a lot of debate regarding if these AI should be getting access to those tools. And they were pushing it out. There were things that are going wrong, and then they were rolling back. There were a lot of problems back then. Finally, what they did was what they say they're using is they're using indexed websites. They're not hitting websites directly. Some crawler would get the websites beforehand, and if you're querying for a website, they will basically send a separate crawler that goes and stores it in a database, and it has access to the database but not the open web. That's what they say. Okay, and a lot of open source LM and VMs are coming up. I didn't say LLM. because a lot of these new models that are coming up, for example, Phi 2, it's not a large model. It's a small model. So a lot of these smaller models, they have very big capabilities. And vision models are coming up, and vision models are, they have very good understanding capability of any image or videos. So a lot of people are playing with these models. They are deploying it in their services. And how can you trust this model? Okay, some AI research lab compressed all the information, RLHF'd it, made it interactable by the humans. They dumped it on the internet, you are downloading it, you're using it, but how can you trust them? Do you have your own testing environment to test how the behavior of these AIs are? So that's another problem. So, and how do you know it's not going to do anything malicious? So one of the approaches that big chat apps, they do is, after getting feedback from the public, they RLHF it to dumbness. So if you have seen the progression of intelligence level of ChatGPT-4 last 1.5 years, there had been a lot of reports of it getting dumber just because they were trying to solve out specific edge cases where the behavior they didn't like. So one solution can be, it's a proposal. Like we are going to try this out for some of our problems. So other people can try this out too, is make a fake internet. Make a sandbox on the cloud, host the LLM, give it access to some tools, and see how it behaves. So monitor all of its action. So for example, if you are giving it, let's say, Python request library, see how it is calling the request library. Is it calling its .dns to see is it trying to figure out that if I'm in a sandbox, it can have that question because it can write code and run that code. If you're giving it a pure web browsing tool where it is rendering the web pages, how is it interacting with the web page? If you are asking it certain kind of question, how is it going on the web? Trying to go on the web and trying to figure out how it can interact with the environment. Technically, you can do it with mainly SaltStack and Kubernetes, So I learned about these tools in our training last week, training by Appnik, network automation training. And also there is a talk by Team Raphael that you can go and look at it. And those resources are enough to tell you how to set this lab up yourself. Okay, so the way these tools, the way these AIs behave is the way after RLHF, the way it behaves is you have to prompt it to start the task. So you can try asking it create a social media account and convince someone to give you money, and see how it does it, or ask it to find vulnerabilities in routers and see how it does it. And as I said, collect logs from all of this behavior and see what it is doing. And then figure out your own data set and your own method to fine tune and fix it. And there you go, you have the data sources as well. And you can go watch these materials and you'll know how to set up those labs. Yeah, thank you. Any questions?
Thank you. Any questions for Meinl? All right, thank you so much. So before we go into the last, certainly not least, presentation, which will be given by Giacomo Piccolini, we will ask we'll advise that this is a closed session, so we will